Let me start with the meaning and magnitude of climate change in the Arctic and start that with just a brief reminder on the relationship between climate and weather. Climate is the pattern exhibited by the weather for a particular region and a particular season. We express climate as average values, typical highs and lows and extremes, and not just of temperature, but of humidity, rain, snow, winds, storminess, and the lengths of seasons as observed and averaged over a period of decades. How climate is changing over time is expressed most simply as the change in the year-round average air temperature for a region or for the globe. But it's important to understand that very small changes in that index reflect much larger changes in aspects of weather patterns, which are what matter most to humans and ecosystems. And most importantly, when average temperature changes a little, the frequency and magnitude of extremes, not just of temperature, but also of other weather variables, change a lot. Globally, the annual average surface temperature was about 1 degree Celsius warmer in the period 2005 to 2016 than in the last decade of the 19th century. Extremely hot days over this period became much more frequent, extremely cold days much less frequent. Rain and snow increased on the average, but now more comes as rain and less as snow, a higher fraction of the rain coming in extreme downpours, and higher losses to evaporation and flood runoff and earlier snowmelt mean almost paradoxically that many regions are drier than before, even though precipitation in total has increased. In the Arctic, temperatures have gone up 2 to 5 times the global average, and the changes in other climate features in the Arctic have also been very rapid. Here you can see the global temperature trend going all the way back to the late 1800s and up to the present. 2016, of course, as you probably all know, was the hottest year on record, 2015 the second, 2014 the third. Every decade since the 70s has been warmer than the last. And this shows the degree of amplification of the temperature increase in the Arctic. This is for the period January to March 2016. And the comparison in degrees C is how much warmer it was in January through March 2016 compared to a baseline of 1951 to 1980 in that particular season. For the world as a whole, during that season, the world was 1.25 degrees warmer than the average in the baseline period, but in the Arctic, it was 4 to 9 degrees C warmer than the average for the globe in that period. So what have been the impacts of climate change in the Arctic? First, the impacts within the region. Shrinking sea ice, obviously. The area of Arctic sea ice in late summer is over 40% smaller than in the late 1970s. Ice volume is down by even more. More open water, of course, means increased maritime activity, new fishing and seabed resource development opportunities with potential economic benefits, but new challenges for oversight, search and rescue, international interactions. And open water instead of ice also means bigger waves and loss of shoreline protection, which leads to coastal erosion and damage, even evacuation for local settlements, and that's all made worse by sea level rise. It means feeding, breeding, and survival challenges for seals, walruses, whales, and polar bears, all of that impacting subsistence hunting for the indigenous peoples of the region. And more absorption of incident sunlight, therefore increased heating, accelerates further temperature increase in the Arctic. This is just a depiction from the National Snow and Ice Data Center of monthly average Arctic sea ice extent in September, the year of the minimum, through this year, through 2017. That rate of sea ice area coverage decline, the rate of decline is unprecedented in at least the last 500 years. We are seeing an increase in the frequency and intensity of the most powerful storms in the Arctic. This shows from the decadal averages from the 50s to the first decade of the 21st century, showing storms, total number in black, and storms with open water in red. Coastal erosion and Shishmaref, many of you have seen images like this before. Walruses hauled out In August of 2015 near Point Ley, that haul-out followed the early disappearance of sea ice in 2015 from the favored feeding area of the walruses on the Hannah Bank. Shrinking land ice. Mountain and coastal glaciers across the Arctic are shrinking. Lots of consequences of that, and it adds up to 75 billion tons of ice annually in Alaska alone. The Greenland ice sheet, of course, is experiencing both surface melting and acceleration of the flow of major coastal glaciers to the sea. Water on the surface from that surface melting increases the absorption of sunlight, accelerates the whole process. Total loss of ice from Greenland is averaging between 250 and 350 billion tons per year. That's up fourfold in the last 2 decades. This shows the decline of glacier mass across the Arctic in the different parts of the Arctic, and this shows the loss of ice from Greenland and shows that loss is accelerating. Thawing permafrost. High proportion of the land in the Arctic and subarctic is in the permafrost region. In the state of Alaska, the percentage is 80% permafrost. And of course, as soil temperature rises along with air temperature, the upper layers of permafrost in the warmer regions start to thaw. That's happening over more and more of the permafrost region. That has a lot of impacts. Land subsidence, threatening buildings, roads, energy infrastructure, increased vulnerability to coastal erosion and wildfires, exposure of previously frozen soil carbon to be released as carbon dioxide and methane. Just some pictures of impacts of thawing permafrost, one from Russia, one from Fairbanks, Alaska. Expanding wildfires. We have higher temperatures, drier landscapes, trees killed by insect infestations, and more lightning. All of those things related to climate change, and that means more, bigger, and hotter wildfires. The combined acreage burned in wildfires in 2015 in Siberia, Canada, and Alaska just by early August was about 13 million hectares. In Alaska, the annual number of large wildfires has doubled since the 1980s, and the average annual area burned has quadrupled. Wildfires, of course, destroy infrastructure, timber, and habitat. They create massive smoke pollution. They directly add large quantities of carbon dioxide to the atmosphere, again, accelerating the whole process of climate change. And they expose soil carbon to microbial action, producing more carbon dioxide and also methane, I should add. And they contribute to the further process of permafrost thawing. And in fact, now even the tundra is burning. It used to be that wildfires in the Arctic were burning in the forested areas. Now they're burning in the tundra as well. Ocean chemistry is changing everywhere, but particularly up there in the Arctic. In addition to reduced salinity and increased turbidity as a result of increased discharge to the ocean of this glacial fresh water, the Arctic Ocean is becoming more acidic, and it's intensified there by the combination of low temperature and low salinity. The effects of that acidification include impacts on marine organisms that make their shells or their skeletons with calcium carbonate, interaction with salinity changes and changes in temperature to alter ocean circulation, and the impact of all of that together on marine fisheries, with consequences that are still largely unknown but starting to be understood, starting to be explored, and potentially severe. Beyond the region, what's happening in the Arctic is not staying in the Arctic. Regionally, impacts on human health as well as on visibility, sunlight reaching the ground, and atmospheric heating from long-distance transport of smoke from Arctic wildfires. Changes in Northern Hemisphere circulation patterns, blocking highs, jet stream slowdown and waviness, bringing polar vortex phenomena to mid-latitudes because of faster warming in the Arctic. And globally, of course, we are seeing an acceleration of global sea level rise as glaciers and the Greenland ice sheet lose ice as a result of warming. And as already mentioned, we are seeing increased release of carbon dioxide and methane from wildfires, microbial action on organic carbon previously frozen in permafrost, and thawing methane hydrates in soils and sediments. This is a picture of smoke from Siberian fires reaching all the way to the northwestern United States in April 2015. This is a depiction of two of the impacts of Arctic change on mid-latitude weather, very high confidence impact on blocking highs, and with somewhat lesser confidence, but recently increasing evidence, the waviness in the jet stream bounding the polar vortex, producing alternating cold weather penetrating southward and warm penetrating northward. The future of Arctic climate change. Continued Arctic change absent large global emissions reductions. The IPCC assessment most recently projected that under business as usual emission growth, the Arctic in the last 20 years of this century would be 4 degrees C warmer than in the last decade. Sea ice, under business as usual emissions, the sea ice in the Arctic Ocean could disappear altogether in late summer as early as 2040, no later than 2100. Wildfires, we project another doubling in annual area burned in Alaska by mid-century, similar growth expected across the Arctic. Sea level rise, of course, a wide range of projections depending on emissions and on how rapidly the Greenland and Antarctic ice sheets disintegrate, but the high end extends to more than 2 meters above the level at the turn of this century. So what can we do? Meeting the challenge together, the needs in monitoring, assessment, and action, and how we build on existing efforts. First, monitoring and assessment. We need to collaborate on geographically denser, more comprehensive, more continuous measurements and monitoring of Arctic climate change and its impacts. We need to improve our understanding of the challenges and opportunities around climate change in the Arctic through data sharing and cooperative research and assessment on, among other topics, the climatic, ecological, and socioeconomic processes that shape climate change in the Arctic, its impacts, and society's responses, and of course, improve technologies for energy supply and end use for reduced emissions and increased efficiency and resilience. Mitigation. We need to recommit, all of us, not only to meeting the Paris intended nationally determined contributions for emissions reductions, but we need to commit, again, to increasing ambition in emissions reductions going forward. We need to work together across national, state, provincial, local, and tribal governments, the private sector, academia, and civil society to identify and deploy cleaner, more efficient technologies for energy supply and use. We need to work together similarly to make available the data, information on best practices, and financing to help communities, businesses, and individuals reduce their vulnerability to sea level rise, powerful storms, coastal erosion, to wildfires and thawing permafrost, to declines in commercial and subsistence species. We need to build on existing efforts, advance the activities of the Arctic Council with its 8 members, its 12 observers, and its many permanent participating indigenous groups. Advancing those activities would include advancing the recent agreement on international cooperation in scientific research, and of course, advancing the Exploring Common Solutions theme of Finland's chairmanship of the Arctic Council from 2017 to 2019. I think we should consider regularizing the wider meetings of foreign ministers on the Arctic that President Obama initiated with the Glacier Conference in September of 2015, which was attended by foreign ministers or their representatives from 22 nations and many representatives of indigenous groups. I would be very pleased if each chair of the Arctic Council in succession organized one wider meeting like the Glacier Conference organized by President Obama and Secretary Kerry during the U.S. chairmanship. Obviously, I think we need to continue the Arctic Science Ministerials. The first one I hosted in the White House in September of 2016, 25 nations and 6 indigenous peoples groups represented there. The second is scheduled to happen in Germany in October 2018, co-hosted by Germany, Finland, and the EU. I think we need to strengthen national governmental coordination of Arctic activities. Examples from the United States, the Arctic Executive Steering Committee, which I had the privilege of chairing for its first 2 years of existence through 2015 and 2016, the Arctic Research Commission, the Interagency Arctic Research Policy Committee. And we need to strengthen, proliferate, and link academic and civil society initiatives. Again, some U.S. examples, the Polar Initiative at the Wilson Center in Washington, D.C., the leadership of the center and that initiative present here. The Arctic program of the Fletcher School of Law and Diplomacy at Tufts, again, the leadership represented here at this meeting. and a new initiative, which I'm pleased to announce here at the Harvard Kennedy School, an Arctic initiative, which I will lead together with my colleagues Henry Lee and Hatla Logodatir at the Belfer Center for Science and International Affairs. We will be focusing on the challenges and opportunities at the intersection of Arctic climate change with sustainable economic development, with infrastructure issues, with environmental conservation, and with indigenous peoples issues. And we will also focus on training a new generation of Arctic leaders, represented here by the Arctic Innovators Lab, which will be meeting this afternoon. And of course, all of this in collaboration with other Arctic initiatives in the United States and around the world. Thank you very much.